So in this question, we have like a set of tiles numbered 1 through 100 that is modified repeatedly by the following operation. So we need to first remove all tiles numbered with a perfect square and then renumber the remaining tiles consecutively starting from 1. We want to know how many times must the operation be performed to reduce the number of tiles in the set to 1. So I think this question is not like one of the best questions because I feel like one of the easiest way to do these questions is to like just brute force it out. So a lot of times, like if you look at a question and you can't think of like a smart way to do it, a lot of times like doing it the stupid way, like might be a good idea. Like sometimes you just like list them out or like, do the entire thing. Like sometimes just doing it the dumb way might be faster than like actually trying to look for a smart way or something like that. So in this case, we have like the numbers 1 through 100. So the idea is like, from the numbers 1 through 100, there are going to be 10 perfect squares, right? So 10 perfect squares, 1 squared, 2 squared, 3 squared, 4 squared, all the way up to 10 squared. So there are 10 perfect squares in this range. So in one move of this process, we're going to go from 100 tiles and we're going to delete 10 of these tiles. So we're going to remove 10 of these tiles and we're going to get 90 tiles left. And then we're going to repeat this process again. So from 1 through 90, there are going to be 9 perfect squares, right? 1 squared all the way up to 9 squared. So we're going to remove 9 tiles. So like 90 minus 9, 81. And then we repeat the process again. Like 81, if you were to do the process again, there are 9 perfect squares from 1 to 81, right? 1 squared all the way up to 9 squared. So again, you're going to remove 9 tiles. So you're going to get 72. And then again, like up to 72, there are 8 perfect squares, right? 1 squared all the way up to 8 squared. So you're going to remove 8 perfect squares. So that's going to become 64. And then at 64, there are another 8 perfect squares from 1 to 64, right? 1 squared all the way up to 8 squared. So you're going to remove 8 of these tiles again. So it goes to 56. And then at 56, there are like seven perfect squares, 1 squared all the way up to 7 squared. So it turns into 49. And then from 49, there are 7 perfect squares. So you remove 7 tiles and you get a 42. And you could continue this process, but like just to like speed up the process, we can kind of notice a pattern, right? So we found that we removed 9, then we removed 9. And then here we removed 8, and then we removed 8. And then here we removed 7, and then we removed 7. So we can tell that like it's kind of like a pattern, right? We first removed 9 tiles 2 times. Then we removed 8 tiles 2 times. And then we removed 7 tiles 2 times. So if we continue this process, we're going to remove like 6 tiles. So that's going to go to 36. We're going to remove 6 tiles. It's going to go to 30. We're going to remove 5 tiles. It's going to go to 25. We're going to remove 5 tiles. That's going to go to 20. And then we can go to like 4 tiles, which goes to 16. Then we remove 4 tiles, that goes to 12. Then we remove 3 tiles, that goes to 9. Then we remove 3 tiles, that goes to 6. And then we would remove like 2 tiles, so that becomes 4. And then we remove 2 tiles, that becomes 2. And then finally, once we have 2 tiles left, we're only going to remove 1 tile, right? Because from 1 to 2, 1 is the only perfect square. So we remove 1. And then now we only have 1 tile left. So then like we would be done. So I guess now what you can do is you can just count them. So I don't think I'm going to take the time to count them. Like you can just like count like how many steps this would take. And you just carefully count them. And you just find that answers would be like C, which is like 18. So yeah, so I think this question wasn't like that like impressive or anything. It was just like you kind of like list stuff out, and you just list them out carefully. And like I guess like you can kind of like speed up the process when you notice that like you see the number 9, 9, 8, 8, 7, 7, 6, 6, 5, 5. Like you notice that like there's kind of a pattern there. You remove 9 tiles 2 times, and you remove 8 tiles 2 times, and you repeat that so on. And like just listing these out really shouldn't take that long. It should take like 1 or 2 minutes during the real test. So honestly, doing it like this dumb way, this seemingly like not smart way, just listing them out, like it can be pretty fast actually. and then you just count them one by one, and you get like that. It takes 18 steps, 18 operations.